We'll now introduce value at risk, usually abbreviated as VaR. VaR is one of the most widely used market risk measures and at the same time one of the most commonly misunderstood. So before we compute anything, it's important to be very clear about what VaR actually measures and what it does not. At its core, value at risk is a quantile-based risk measure. A one-day VaR at the 95% confidence level answers the following question. What is the loss level that will not be exceeded on 95% of trading days? In other words, VaR defines a threshold, not an extreme. Most days are better than this threshold and a small fraction of days are worse. The confidence level is often a source of confusion. A 95% VaR does not imply that large losses happen once every 20 days in a regular pattern. Losses can cluster and VaR exceedances can occur close together, especially during stressed market conditions. VaR is a statement about long-run frequencies, not short-term guarantees. In practice, VaR is almost always expressed in monetary terms. Once a VaR return threshold is estimated, it is just scaled by portfolio value to obtain a potential loss amount. This makes VaR easy to communicate and easy to compare across portfolios or trading desks, which is one of the main reasons it became so enormous popular in risk management. Equally important is understanding what VaR does not tell us. VaR provides no information about the severity of losses beyond the threshold. Two portfolios can have the same VaR and radically different behavior once losses exceed that level. VaR also does not capture path-dependent risks, such as prolonged drawdowns, where losses accumulate over time rather than occurring in a single day. Because of these limitations, VaR should never be used in isolation. In the next section, we'll start by computing historical value at risk, which uses the empirical return distribution directly. This will give us a concrete baseline before we move on to model-based approaches.